All right, name is Brandon Clayton of Algebra Guy. Today we're going to be talking about, as you see on your screen, model improper fractions and mixed numbers. So if you don't know what an improper fraction is or a mixed number, stay tuned. I'm going to show you what those are and how to convert from one to the other, a very important skill. So here are the questions that we're going to answer today. So as you can see, what is a mixed number? What's the difference between a proper and an improper fraction? How can we use the models to rewrite mixed numbers and improper fractions? And lastly, how do we convert between improper fractions and mixed numbers? All right, so what is a mixed number? A mixed number consists of a whole number. Like right here in place of A, you'll have a whole number. And we're going to call that A. I'll put it right there. And a fraction, this BC part is the fraction, where C is not equal to 0. So we never want to divide by 0. So sometimes, pretty much all the time when you see a rule, they're going to say don't make that 0. So here is a mixed number. So let me give you some examples in case that point still didn't draw home. Here's what a proper, I'm sorry, we'll do that in this next one. Previously, we used fraction circles to make wholes using 8/5. This could have been written as a mixed number. So we could have written 8/5 as a mixed number. We could have wrote, instead of 8/5, make this a little smaller. So we could have wrote it a different way as a mixed number. We could have wrote some number here. In this case, it would have been 1 3/5. These are both the same thing, and you'll need both when solving problems. So let's get to it and find out how to handle both of those. The fraction AB is a proper, and when I write AB, by the way, just remember that A over B, it says these two are the same thing. That slant just is on the side as opposed to like this. It's the same thing. The fraction AB is a proper fraction so when is it proper? If A is less than B. So if the number on top is less than B, it's a proper fraction. And if A is greater than or equal to B, it's a improper fraction. So it's improper. It's like not having the right manners or something, right? So it kind of sounds like that. So improper. And now here's some examples to draw this point home. This is what I was trying to get at. Proper. Notice that the numerator, the number on top, is less than the number on the bottom, the denominator. So for all of these, that's true. These are considered proper. Obviously, improper is the number on top is bigger. Or, check this out, the number on top is equal to, right? Because it also says equal to. So 5 over 5 will be considered an improper fraction. All right, our question here is, name this improper fraction that's modeled. So let's count and name what this improper fraction is. So anytime you have more than one, so we have one circle here, but we obviously have more shaded regions than just this one circle. And we know that's going to be improper. Matter of fact, if all of them were circled like this, that's improper because the numerator is going to be equal to the denominator. So what are we looking at? We're looking at a fraction. And we know that the denominator tells us how many parts is broken into. So this is broken into 3 parts, so each part is worth 1/3. So we're dealing with thirds here with both circles. So I know this is broken into thirds, and there's 3/3 here because it's 1, 2, 3, and there's 1/3 here. So I add those together, 1/3, 3/3. I get 4/3. So they want an improper, and so I made the number on top bigger. I didn't make it bigger. It's actually bigger because you have 4/3. 1, 2, 3, 4/3 of this circle. And that's how you write that. All right, so now we've done that. I forgot about that part. So we have 4/3. Now let's write it as a mixed number. So a mixed number says I need a whole number in front. So this is going to be equal to writing it as a whole circle. I didn't have to say 3 over 3. I could just say 1 whole. Because 3 over 3 is the same thing as 3 divided by 3, which is 1. So this is the same thing as 1. I got 1 whole circle shaded, so that's 1. I took care of that part. And how much do I have shaded here? Hopefully you're saying 1/3, right? 1/3. So I could have written that instead of 4/3, I could have written it 1 1/3. So both the exact same thing. All right, let's work this problem out. Draw a figure to model 11/8. So now we're going backwards, and they're asking us to draw a figure. Instead of giving us a figure, they're asking us to draw a figure that represents this. So I'm going to draw, let's do a circle. We could do a rectangle, but circles are much easier to break down. So I'm going to do a circle, and I'm going to use, I'll just use my pen to draw this straight line. So I'm going to break this into 8 pieces, right? Because we're dividing it, whatever that unit, which is a circle, into 8 pieces. So that's 2 pieces, that's 4 pieces, 6 pieces, and 8 pieces. Ah, that's not that perfect. Oh my goodness. Let's go back. Let's try that again. Bam, that's pretty good. So freehand, I'm pretty happy with that. Now, what am I trying to do with drawing this? I'm trying to keep all the sections equal, because when talking about fractions, they're assuming that you divide them all into equal parts, right? You don't want to draw a circle and have a little slit over here and then another piece over here, and then that's not what they mean. So we're assuming that all pieces are drawn equally. We want 11 of these pieces. So 11, well, I only have 8 pieces here. So if I shaded in all of these, 1, 2, this is me shading, by the way. Just assume that this is a pie. I'm shading it all in. So that's how many shades right there. I have 8 out of how many pieces? 8. I have 8 out of 8, but I need 11 out of 8. So I'm going to have to add another circle. And what are we going to divide this circle into? Well, it told us we're still dividing it by 8 because we want our pieces to be in eighths. Kind of hard to say eighths, but there you go. All right, so let's try this again. 1, 2, 3, 4. It gives me 8 sections, and now I have 8 here. It looks like to get to 11, I'm going to need 3 more. So I'm going to shade in 1, 2, and 3. So this model here shows us 11/8 because I have now 3 out of 8. And 8 out of 8 and 3 out of 8 gives us 11/8. So if I were to take this circle away and just kept the pieces of pie left over, I would have 11/8 of a pie. Yes, that's right, 11/8. Try asking that amount for dinner or for a holiday, right? Can I have 11/8 of a pie? And see what your responses are. You'll get a whole pie plus 3/8. No, you won't get that. You're probably going to get a funny look. So don't do that. 11/6. So let's do 11/6. Use a model to rewrite the improper fraction as a mixed number. So first it says use a model. I like using a circle. And we're dividing that circle into how many pieces? 6 pieces. Good. You said it. Hopefully. Bam. And let's see. I got to make this one kind of even. Bam. And that is pretty good. Brandon, good job. I'm patting myself. That is a good circle. All right. So I want 11/6. I know that 6 out of 6 is over here, right? 6 out of 6. I'm just kind of shading it for your benefit to know that this whole circle is taking up 6 out of 6. I don't need 6 out of 6. I need more. So I need to add another circle here. And you're probably already ahead of me, know what I need to do, but just bear with me while I catch up with you. So I'm going to divide this circle into 6 pieces too, because I need my pieces to be in sixths. Bam. And how many more 6 do I need? Well, I got 6 over here. I need 5 more 6s. So 5 more 6. So if I shade it in, 1, 2, 3, 4, 5. This represents 11/6. This whole thing represents 11/6. And we're being asked to change this into a mixed number. Well, I already have 1 here, right? This whole thing is just one whole thing. And this is 5/6. So this is going to be 1 and 5/6. Easy enough, right? Did I do that on the last problem? I'm wondering, actually. Did I change that to a mixed number? I feel like I should have. So let me see. No, they just wanted us to draw the figure. Okay. All right, so we did that. Any questions? Good. All right, no questions. 6 out of 6 plus 5 over 6 gives us 11/6, and we change it to a mixed number, and we're ready to move on. Let's erase that and go to our next one. Use a model to rewrite this mixed number as an improper fraction. All right, so we want a model to do this. I'm going to get a whole piece. Why? Why am I getting a whole piece, actually? Well, because it says right here 1. And I know there's going to be one whole piece, and it looks like it's going to be a little bit more, so I'm going to go ahead and draw 2 circles. I'm going to draw another circle. And I know these are going to be added together. What am I going to break this circle into? What pieces? I'm going to divide it into fifths. All right, so how do I do fifths? Fifths is going to be like a pentagon, like a person with their arms out, right? Bam, bam. And this one's going to be into fifths also. Bam, bam, bam. That's not as good as my first one, but you get the point, hopefully. So 1 is going to be represented. All of this needs to be shaded. This is 5 out of 5 gives me 1. 6 out of 6 gives me 1. 7 out of 7. Any number over itself gives you 1 because that number divided by itself equals 1. So I already have 1 here. What is this one? This is 4 over 5. So 1, 2, 3, 4. I think I drew this one much bigger, but that's all right. So we got 5 over 5 and 4 over 5 gives us 1 and 4 fifths. So this is 1 and 4 fifths. That's how they got it. But the question they're asking us is to make it improper. So we need to make it where the numerator is bigger. So let's keep the 5 over 5 and the 4 over 5 and think about what that is added together. Well, how many fifths do I have? 5 here. I got 4 fifths here. When I add them all, I got 9 fifths. Boy, that's hard to say. 9 fifths added up all together. So I'm going to circle that so we know that that's our answer as an improper fraction. All right, so improper fractions into a mixed number. How do you go backwards? So we just did that, but what if you try to do it without a model? Can you do that? And I want to encourage you to definitely do that because you're not going to be able to draw models for everything. It's not going to be, you don't have the time and you don't want to spend extra time doing something you don't have to do. So let's talk about how to do this without a model. First, we divide the denominator into the numerator. So let's take 11/6 for instance. So we got 11 divided by 6. And there we go. So check. Bam. Did it. Finished. Nope, not quite. We got number 2. Identify the quotient, remainder, and divisor. So do you remember the different parts of this? Let me solve it because it looks like I got to do that part. 6 goes into 11 once. 1 times 6 is 6. 11 minus 6 is 5. All right, so we end up, well, actually, let's leave like that. So now we get to part 2, and we need to identify what the quotient is. So here's my quotient. Quotient is the answer that I get. And remainder, what's the remainder part? I'll leave it pink. So this is my remainder. And the divisor. So we're dividing 11 divided by what? What is the divisor? So this is our divisor, 6. So remember what we're trying to do. We're trying to take this into a mixed number. You know, a mixed number is some whole number here over with next to a fraction. You know, that's how it should be set up. So how is this going to help us do that? Well, now we write the mixed number as a quotient. So write the mixed number as a quotient. Mixed number as a quotient. So we're going to use 1 and 5. So we take our remainder, 5, and it goes on top. And the divisor goes on bottom, 6. And voila, we got a mixed number. Did you know that's what you were doing the whole time when you're dividing? When you're dividing a number, you're already showing what it looks like as a fraction, as a mixed number. It's 1 and 5, 6. As a matter of fact, before you learn to do this, you likely would have continued to go on and put a decimal there and a 0 and continue to multiply, trying to figure out what this number is. And all these numbers you get after that are the decimal form of 5, 6. So we would drop this down and put 50, right? And 6 goes into 50 let's see, 8 times. So that would have been 1.8. And you'll end up with this fraction when you're done with it that equals 5/6. So if you were to just stop right here at the 1, at the whole number 1, you can see what the fraction form looks like, the mixed number form, 1 and 5/6. And that's our answer, 1 and 5/6. We just converted it, didn't have to use a model. All right, so let's try this one. We're going to take our number here. We're going to divide the denominator by, divide the denominator into the numerator. 33 divided by 8. 8 goes into 33. And just to keep in mind what goes where, just remember that this thing you read down, right? 33 divided by 8. 33 eighths. So that's how you're going to write it. 33 divided by 8. 8 goes into 3. Was it 5? No, that's 40. So it must be 3 times. 8 times 3 is 24. And we're going to have a remainder of 9 left over. Just stop right there. Because this is not working out, I can see. Because 8 can go into 9 more times. So I didn't do that, right? I could actually go into them more times. So let me erase that. I should have used 4. And you probably already knew that. But hey, we make mistakes. 8 goes into 33 4 times. That's the biggest because now it gives me 32 minus 33 minus 32 is 1. Now I can see what my answer is going to be. It goes into 4 whole times. I can get 4 whole 8s out of this whole thing. So 4 8s are into this 33. And then what do I have left over? Well, I have left over 1, a remainder of 1 out of 8 and 1/8. Now, after a while, you'll likely be able to do this without even the work. You can just look at this problem here and realize that 8 goes into 33 4 times. And if you take 8 times 4 is 32, take 32 out of 33, you're going to have 1 left over. And that bottom's going to stay the same. So you can do that pretty quickly once you've done enough practice problems, and you'll get the hang of it. People are going to be amazed. Like, how did you know that? All right, let's go backwards now. Let's convert this mixed number into an improper fraction. All right, and by the way, when would you need that? That's a question that comes up. When would you need to do that? So previously, let me go back here. Instead of just doing this work, when might I need to know how to do that? So if I wanted, for instance, if you were adding numbers, let's see, this is 1 and 5, 6. If I was adding numbers, it'd be helpful to know, this is 3, let's come up with 2/3. So it'd be a lot easier for me to say, add these and say 1 plus 3 is 4, and then add the fraction parts of them, than maybe trying to convert these again, or vice versa. So it just makes sense to say I got 1 cup and 1 and 5 6 cups. That's about 4 plus these fraction parts. So just doing some of your operations, you'll find that one way works faster than another. It's also important to understand because you can understand whole numbers better than you can the improper fractions. So you want to think, what is 23/3? Like, what does that mean to me? Well, that means, what is that actually? 7 and what, 1 or 2/3. So you can say, oh, it's about 7. And the next lesson we're going to get into is putting them in order. In order to put them in order, you need to be able to pull out that whole number and see where it is on the number line, and it's not just some fraction. All right, that's the why behind it. Now let's go backwards, because sometimes we want to keep it that way because it's easier to add or multiply. For instance, it's easier to multiply, like if I had this fraction here, and let's say 3 over 2. When I multiply, and we'll talk about this later, I'm going to multiply straight across on the top and straight across on the bottom. Now, if I didn't do that, I would have ended up with 1 and 5/7 times 1 and 1/2. It's a lot tougher to multiply these two then I could have just went straight across and got my numbers and undid it at the end as a mixed number. So, but we'll talk about that. I just want you to understand the value of what we're doing in case you want to see the big picture. So let's go backwards now. Let's take this number and put it into an improper fraction. How do we do that? So we multiply the whole number by the denominator. So we're going to take this number, let's say that this is equal. We're going to say this 4 times the denominator. 4 times the denominator, and we're going to leave it in the numerator. Add the numerator to the product found in step 1. So now we're going to add the numerator to this. So what is the numerator? That's 2. So we're going to say plus 2. And write the final sum over the original denominator. So we're going to keep this denominator the same. And most time in the fractions, you're not going to mess with that denominator after this manipulation because it's still divided into that many pieces. We just want to know how many pieces is that. So we're going to keep that third there. Now we do our math. 4 times 3, because PEMDAS tells us to do multiplication first. So it gives us 12 plus 2 is 14. And that's 14 over 3. So we have now converted it back. Let's do another one because that went by kind of quick. But let me review that. We did 4 times 3, which is 12, plus 2 is 14. And left it over 3. What about this one? So I can talk through this one really quick. 10 times 7 is 70, plus 2 is 72 over 7. But let me work it out in case you want to see that in slow motion. So we take our whole number, multiply the whole number, which is 10, times the denominator. So that's going to be 10 times 7, and add the numerator to it, plus 2. And all over what the denominator already was. Do your math. 10 times 7 is 70, plus 2 is 72, all over 7. Voila. Wow, that was beneficial and that was very necessary and rich. So what is a mixed number? We talked about that. Matter of fact, we just finished on what a mixed number was. We just have, here's an example, a whole number combined with a fraction. What's the difference between a proper and improper? Proper, the number on top is lower than the number on bottom. Improper, the number is bigger on top or equal to the number on the bottom. How can we use models to rewrite mixed numbers in proper fractions? We showed that using the circles. When they asked us for 5/3, for instance, we could draw models, put these in thirds until we got all the thirds that we needed to make 5. How do we convert between improper and mixed? That was our last example. And we showed we could take the number on top. Here's an improper. Let's say, that's too easy. Okay, let's do this one. 4 and 3. So how do we convert between improper fraction and a mixed number? 14 divided by 3, and we showed that. So we just take that number divided by here, and that'd be 4, 12. My remainder is 2, so my answer is 4 and 2, because that's my remainder right there. Oh, I'm not doing that pretty at all. Sorry. All right, 4 and 2/3. 14 over 3. So that's how we showed how you would do that. Just literally take that fraction and divide it the way it says. 14 divided by 3. And stop at the whole number and record what you have as a remainder, divisor, and quotient. Guys, thanks for tuning in again. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.